Okay, so hi, I'm Kelvin. I work at Optimism, and I'm going to be talking a little bit about how to handle fees on layer 2. And this is an interesting problem because it's sort of one of the last remaining annoying problems on layer 2 that has, at the moment, no perfect solution, right? So I think almost every single problem on layer 2 is kind of a solved one. This one has a reasonable solution, but none of them are great. And so I want to talk to you about that, and then I want to talk to you about the next steps, so where I want to go with this. All right, so AKA, why the heck are fees so hard to deal with on layer 2? So the big question is, how should fees be charged on layer 2? And this sounds like, it sounds like a pretty straightforward question. I don't mean like, how do you decide what the gas price is going to be, nothing like that. Just literally, how do you charge the user fees? And the goals, if you're going to design a layer 2, the goals of a system like this should be, number one, it should feel like Ethereum because we like Ethereum, because people are used to the Ethereum developer experience, and because changing Ethereum creates headaches. So if I've learned a single lesson from designing layer 2s, it's that anytime you slightly modify the EVM, you're going to break someone's workflow. It's like that XKCD, where someone's relying on like the fan overheating to do something. Any small behavior of the EVM is something that somebody somewhere relies on. And so when you make changes, 3 months down the line, somebody's going to complain, and they're going to say, you broke my server because some RPC doesn't work perfectly like it does on Ethereum. So these are the goals. It should feel like Ethereum. But of course, it should also be incentive compatible. I should actually be able to charge people accurately for the resources that they are using on layer 2. Otherwise, people can just get away with using resources that they're not actually paying for. So these are important goals. But you have these sort of big issues. And essentially, the problem is that layer 2 is not the same as layer 1. As much as it's similar, it's not exactly the same. And importantly, the cost of call data is quite different, right? On layer 1, you have this relationship between the cost of call data and the cost of execution. And this relationship remains mostly fixed most of the time, right? We have currently, per non-zero byte of call data, you pay 16 gas. This is a fixed number. It just stays there. And over time, we've reduced this slightly to reflect changes in sort of requirements and hardware. But generally, this relationship for periods of months or years stays the same. And so on layer 2, this changes immediately, right? Because if you think on layer 2, the majority of the cost for a transaction actually comes from your call data. This is not the case for many transactions on layer 1. So the immediate relationship between gas and call data is broken. But not only is it broken, it's broken in this way where you can't just take call data and suddenly charge 2,000 gas per byte. Because actually, the cost of call data is constantly fluctuating with the price of gas on layer 1, because we have to post these transactions to layer 1. So you have this problem where call data is now this dynamic value that fluctuates independently from execution on layer 2. And so we can't just port over the way that the EVM handles gas on layer 2. Right, so this is sort of if you want to naively fix this problem, you just change the cost of the call data opcode, opcode. You change the cost per byte of call data, right? But like I just said, the issue with this is that the cost is not like a sort of constant sized increase over the current cost of call data. It's this constantly fluctuating value, right? When there's an NFT drop on layer 1, all of a sudden, it costs 10 times more to post your transactions to your layer 2 transactions to layer 1. So we have some models for fixing this problem, and I think there's sort of the main idea is quite simple. You want to charge dynamically for the data that your transaction uses, right? That's the goal we want to achieve. And as L2s, we've kind of settled on two ways to handle this problem. The first way is that you can take the cost of a transaction in terms of layer 1 gas, and you translate this into a certain amount of layer 2 gas, right? So if it costs me, 100 ether, this is a totally arbitrary value, never gonna cost you this much, but if it costs you 100 ether to publish a transaction on layer 1, you know it's gonna cost you that much money. Then on layer 2, what you can say is, okay, I'm gonna look at the current layer 2 gas price, and I'm gonna charge the user a certain amount of layer 2 gas such that the amount of gas used times the current layer 2 gas price gives you 100 ether, right? And you can kind of imagine why this works. It's pretty straightforward. You get this dynamic charge. But you can also sort of start to imagine the difficulties that this creates. All of a sudden, the same transaction, when executed at different times, is actually going to cost different amounts of gas. And this creates developer experience problems, right? So some people will rely on hard-coded gas limits, and if you use this methodology, then hard-coded gas limits won't always work. And so you either need to start pushing everybody to use gas estimation, and most people already do that, so it's not a huge problem. But then there are certain people who simply can't do this, and you can kind of get away with it by setting a very high gas limit that is so high that it's sort of you're never gonna run into this issue. But you create this weird discrepancy between the way that layer 1 and layer 2 works, and it creates, anytime you have a discrepancy like that, it creates mental overhead for developers. So you really don't want this sort of discrepancy. The other option, which also has its own issues, is to sort of directly charge for gas on layer 2. Directly charge for the cost of publishing your transaction from the user's account on layer 2. So you can imagine, or the way that this would work is just, if you compute that it's going to cost you 100 ETH to publish a transaction to layer 1, then you simply just deduct 100 ETH from the user's account on layer 2. But this also has its own sort of major problem, which is that with the current transaction formats, there's no way to limit how big that charge is going to be. And so you can do things like sort of do this smoothing on what the layer 1 gas price is, but ultimately if sort of the estimated layer 1 cost goes up very, very, very high, the user's just gonna get charged whatever that number is when their transaction gets executed, right? So you suddenly have this problem. In practice, it's not a massive issue, but in theory, it is a security problem that we need to address. So none of these things are ideal. You're trading off somewhere in developer experience, in security, it's just none of these solutions are fantastic. You can also do this deranged thing that we did at Optimism a long time ago, which was a terrible idea, and we moved away from it, but it was a lot of fun, where we wanted to reflect the layer 1 gas limit somehow. We wanted to let people pick a maximum for what they were going to get charged on layer 2 for this layer 1 gas. So something like this direct charge. And so we said, what's somewhere in the transaction where we can encode this information? And so we realized that the gas price is a very big number, right? Usually you have a gas price that's somewhat like, it's like, 3 gwei, whatever. And it turns out there's a lot of lower bits in there. And so you can just start encoding information into the lower bits of the gas price and say, well, the upper bits of the gas price are going to be the layer 1 gas price, and the lower bits of the gas price are going to be the layer 2 gas price. And now all of a sudden you need to go to wallets and you need to get them to do this crazy gas pricing thing. And it was a lot of fun. It was a terrible idea. And we sort of realized that you want simplicity at the end of the day. You do something deranged like this, every wallet is going to hate you, and they're going to want you to change it. So we changed it, but it was fun. Or we just get Ethereum to fix it for us. So a few days ago, there was a workshop, the sort of layer 1, layer 2 EF workshop, and we talked about this problem, and it was brought up that there might actually be a really convenient fix pretty soon. And the better answer is that there's this, if you haven't heard of it, I mean, you're at a layer 2 sort of event-ish, kind of. The EIP 4844 is this fantastic EIP to introduce this idea of sort of data blobs on layer 1. So there's sort of just this area for you to publish large amounts of transaction data to layer 1 very cheaply. And it has the same problem. You have these blobs that are now sort of separate from standard Ethereum transaction gas. And you need to figure out how are you going to charge for these blobs. It's a very different resource. And it has the exact same problem. And so it's looking like we're going to need to introduce a new transaction type for 4844, and that it will probably have this convenient field called max fee per blob, which it's going to use, a similar mechanism where you get your account gets charged directly for the cost of your blob transaction data. And this is the same thing that we just described in rollup land, except now it's with blobs, and users need to be able to supply a maximum fee per blob. So you can imagine a universe where you co-opt this, and you come up with like a standardized rule, and you say something like, if a user submits a blob transaction, but there's no blob data, then we're going to treat it as a special layer 2 transaction. You don't do this on layer 1. You only do this on layer 2. You can say, we're going to treat this as a special transaction type on layer 2, where instead of max fee per blob being applied to the amount of ETH that you're going to get charged for your blob data, because there is no blob data, you take max fee per blob and you use it as the limit for the amount that you're going to get charged for layer 2 data. So we sort of started to solve this problem with a convenient parallel to layer 1. Very exciting. I guess the question now, perfect. The question now is, how do we actually get to this nirvana? Realistically, we need collaboration between layer 2 teams. This is an interesting challenge because wallets don't love to do things for just one project, because then you have a code base that you are maintaining slightly different behavior for every single chain. And this is really, you start to get a whole bunch of if statements and switches, and it's not ideal. So you want joint action on this front, and you don't want to create 10 different solutions. So you really do need collaboration between layer 2 teams. And the reality is that if you want a way to create incentive compatible fees, so sort of safe from the roll-up side, and secure fees, so safe from the user side, without sort of breaking the developer experience, there's like only really 1 or 2 ways of doing this. We might as well, all the rollup teams are going to have the same problem. This applies whether you're an optimistic rollup or whether you're a ZK rollup. You have the exact same issue with resource pricing. You need to solve this, and having a sort of standardized transaction format that we kind of hack on layer 2 for our own reasons seems like an ideal path forward, as long as we can all agree on it. And it's also a really great opportunity for everyone to work together. I mean, we kind of get to collaborate and can build a process around how we can work together to do these sort of standards, because standards make everyone's lives easier, and it means that you can reuse a bunch of code. And it's a clear win, right? Everyone I talk to on the layer 2 side has struggled with this problem. Making fees that are incentive compatible and safe for users on layer 2 is hard, and doing it in a way that doesn't break developer experience is almost impossible. So coming up with a standardized way of handling this seems like a really, really easy win. So I'm excited about this. This talk has evolved. Before I got here, it was a lot more depressing, and then the layer 2 or the EF workshop came about and sort of revealed a lot of parallel between layer 1 and layer 2 in this regard. So I think we will also get to see more of these cases where layer 1 and layer 2 sort of have the same problems, and we can end up working together to solve them. But again, if it's 10 different layer 2 teams doing 10 different things, it's kind of like, it limits your ability to actually work together and standardize things. So yeah, that's the end of my talk. This is a very fascinating subject and one that I've been sort of struggling with for the last maybe year and a half. We've overhauled this 3 or 4 times by now. So fees on layer 2, really annoying subject.
Any questions for Kelvin?
Ed. Hey, Ed from Arbitrum. We're totally on board for working with our L2 friends on standards around L1 and L2 pricing and wallet integrations and so on, as you know. But I wanted to ask about trust and trustlessness in the fee setting process. What is your thinking about who or what should be trusted in determining what fees are charged to a particular transaction? Should it be entirely trustless code? Is there a role for trust in the sequencer or other components? What do you think the requirements or goals are as far as that goes?
Good question. I mean, ideally, it should be as trustless as possible. You should be able to get all of your well, okay. There's I think the easy short-term solution is you could make it very trustless, right? You can just say you pull like L1 base fee information automatically from the L1 chain. You can do this very quickly. You could essentially, you can construct this so that you're getting L1 base fee information from every single block on layer 1. So that gives you, it gives you good insight into what fees are looking like on layer 1. I think there's a little bit of room, realistically, you want, if you're just updating fees on layer 1, immediately you get this weird thing where fees on layer 1 spike, and but you can work around that. I know Arbitrum does like fee smoothing so that you smooth out those layer 1 base the layer 1 base fee. I don't see a huge need, at least not now, for having the sequencer come in and say, I'm going to charge you an additional fee. I feel like, at least in the short term, it should be good enough. Do you have any specific use cases where you would say the sequencer should be able to come in and, let's say, charge an additional fee because they see, they know something about how pricing on layer 1 is going to be in the near-term future?
Our approach is that we want to trust the sequencer only for sequencing.
Sure.
And that the sequencer does not have a way to get higher fee or reimbursement returns to itself by manipulation.
Yeah, right. I think that's absolutely the correct target, no matter what. Yeah.
And for one more question. We have a question from Twitter, if no one else has one here. The question is from Carolina Gorna. Would it be possible for optimistic rollups to connect to the Bitcoin blockchain too? Could they improve the current Lightning network or maybe even replace it?
Yeah, so sort of the interesting thing with the way that optimistic rollups are going is that if you're building your architecture well, you kind of just like, it's John Adler likes to say, like, wait, it's all data availability? Like, as long as the data is available somewhere and your sort of validation thing has access, I mean, that's the reality of it. If your data is available somewhere, you can use it. And then within that, it's just about trust assumptions, right? Sure, we can totally just transfer optimism in the future to use it to point to an arbitrary number of shards on layer 1. It doesn't even just have to be on one shard chain. It can be on 10 different shard chains at the same time. And you can sort of just prove like all this data is available, and so you have all the input information to the L2 state. So yeah, you can post this data absolutely anywhere.